Today I'd like to speak about the PLC, or the Programmable Logic Controller, one of the most important workhorses that you can get in industry. These devices come in a whole range of sizes and types, and just looking at the screen you can see quite a variation there. Some of them might be small standalone units which you probably need to give a 24-volt supply to. Others are going to be rack mounted and they can be connected in networks. They literally are going to be controlled by means of a program which you and I will put in, and they will do all of the final control in the plant. They're able to deal with digital as well as analog signals, and these can be inputs or they can be outputs. I've tried my very best to create a three-dimensional image of the PLC, and the area that I've gone and marked out in grey would typically be the rack. These devices would be installed in racks, and you have got the ability to slide your cards in and out as required. One of the most important cards is going to be the power supply card. Now, in the case of the power supply card, it could be that we bring in a voltage such as 220 volts AC, and we bring in the live and the neutral to it. It also could be that these devices have got the ability to give us a DC voltage out, such as plus 24 volts and 0 volts. And this you could take out to your switches or to any instruments that are going to be connected up to the system. Our next important card is going to be the CPU, and you're often going to find that the CPU will be mounted next to the power supply so that it can receive nice clear signals. The CPU is literally going to be the brains of the operation. So this is the part of the PLC that's going to control exactly what happens inside the PLC. Now, a very important part of the CPU is also going to be the memory. The memory is where everything happens. Please note that memory can be divided into two regions, which are going to be volatile as well as the non-volatile memory. The volatile part of the memory can literally be regarded as something such as a scratch pad. This is where all of my current values are stored. This is where there is an operating copy of the program, and all of my counter values and all of my timer values, and any change of status is going to be saved in the volatile memory. Often there's going to be a file that has been created for all of the input states, and there's going to be a file created for all of the output states. Now, when I talk in terms of a volatile memory, what it does is it can store information, but the information is lost as soon as the power is lost. Let me give you a good example. If I was to go and take the word scratch pad at the bottom, I can go and press Control C, and now when I press Control V, it pastes it down, and it can go and paste it down. If I was to go and shut my computer down and start the computer up again and say Control V, it's not going to remember what it had. So a volatile memory is a memory that is going to lose its information when it loses power. So we are going to have a running copy of the program that will be put into the volatile memory, and as the program gets utilized, as the values out in the field change, so this is going to change in the volatile memory. Now compare this to the non-volatile memory. This is where you're going to put in the original copy of your program. So every time you go and write the program and you save it and you download it, it's going to go into the non-volatile memory. Now, this is very much like the read-only memory of your computer. If I was to go and save this page and shut down my computer for 3 years, when I open up the computer again and I open up this page, it's going to open up. Same with that memory that I have got of the program. So it keeps a copy of the program in the non-volatile memory. And literally what happens is every time you start the PLC up, it takes a copy of your program and puts it into the volatile memory. And that's where it gets used, because the volatile memory is extremely fast. In the case of the non-volatile memory, not as fast, but it does have the ability not to lose its information. The rest of the PLC is what I'm going to refer to as the I/O, and I/O is going to stand for inputs and outputs. Any signal coming into the PLC is going to be an input. Any signal going away from the PLC out into the field, such as your valves and your actuators and your variable speed drives, are going to be referred to as output signals. Now you can go and set this up any way that you want to. You might decide you'd like to have a digital input card, and maybe you're going to have another digital input card, and then you're going to have a digital output card, and maybe you're going to have another 2 digital output cards, and you're going to have something such as an analog input card, and you're going to have something such as an analog output card, and you might have another analog input card. You can go and mix and match and make it up exactly as you need to go and do it. All that remains then is just for you to decide on a language that you're going to program in, write the program, test it, get it up and running, and everything else should be perfect after that. And over the course of the next couple of videos, we're going to show you some of the exciting things that you can do when it comes to programming a PLC. Getting back to DCS systems, often the DCS systems are going to have their own equivalent of a PLC, and that will be known as an RTU, remote terminal unit. Generally, we're going to refer to anything that does that job out in the field as an RTU. So an RTU can be a PLC, but does not have to be a PLC. But it certainly is going to work very closely with the rest of the equipment that you have in your plant. Hang around and we'll do a lot of exciting programs.